The night sky has always been a source of wonder for people everywhere. We look up at the countless stars and the bright, shining moon, and we dream. We wonder what is out there, far beyond our own world. This curiosity is a powerful force. It pushes us to explore, to discover, and to understand our place in the vast universe. For India, this dream is not just about curiosity. It is about progress, pride, and securing a better future for its people. Space exploration is a journey that inspires an entire nation, especially its young minds, to think bigger and aim higher. It teaches us that with science and determination, even the most difficult challenges can be overcome. When a rocket soars into the heavens from Indian soil, it carries more than just a satellite. It carries the hopes and aspirations of over 1 billion people. Each successful mission is a testament to the country's growing scientific and technological strength. This journey into space brings tangible benefits back to Earth. Satellites help farmers predict weather, guide fishermen to the best catch, and provide internet to remote villages. They help us manage our natural resources, like forests and water, more effectively. They also play a crucial role in national security, keeping a watchful eye over our borders. The pursuit of space exploration, therefore, is a vital investment in India's development and its future. The excitement around space is infectious. It creates a wave of enthusiasm that encourages students to pursue careers in science, technology, engineering, and mathematics. These are the fields that will drive innovation and economic growth for decades to come. The engineers and scientists working at the Indian Space Research Organization, or ISRO, are national heroes. They show what is possible with dedication and hard work. Their achievements, from sending a mission to Mars on the first attempt to landing a rover near the moon's south pole, have put India in a select group of spacefaring nations. This journey is just beginning, and the path ahead is filled with even more exciting possibilities. As we stand here on January 25th, 2026, we are at a thrilling moment in India's space story. The coming years promise an incredible Odyssey, a series of missions that will push the boundaries of what we thought was possible. ISRO is preparing for an ambitious schedule that includes sending humans into space, returning samples from the moon, and testing brand new technologies that will redefine space travel. This is not just about planting a flag on another world. It is about building new capabilities, fostering international cooperation, and using space technology to solve problems here on Earth. The great cosmic dream is alive and well in India, and it is propelling the nation toward a brighter, more connected future. The Indian Space Research Organization has laid out a bold and ambitious roadmap for the near future. The plan is to conduct a flurry of about 7 space missions before the end of March 2026. This is a very active launch schedule, showing a clear intention to accelerate India's presence and capabilities in space. This intense period of activity is part of a much larger 5-year strategy. The grand vision is to carry out approximately 50 launches in total. This high frequency of missions demonstrates ISRO's confidence in its technology and its commitment to meeting both national needs and the demands of the global commercial market. Each launch is a complex and carefully orchestrated event, requiring immense preparation and precision. This packed schedule involves a variety of missions, each with its own unique objectives and challenges. The rockets that will power these missions are primarily the Workhorse Polar Satellite Launch Vehicle, or PSLV, and the Heavy Lift Launch Vehicle, Mark III, LVM-3. These rockets are the backbone of India's space program, capable of launching different types of satellites into various orbits. The missions planned include launching satellites for Earth observation, communication, and navigation. There will also be important test flights for the Gaganyaan human spaceflight program and missions dedicated to demonstrating new technologies that will be crucial for future deep space exploration. This diverse portfolio highlights a balanced approach to space activities. The goal is not just to increase the number of launches, but also to expand the scope of what India can achieve in space. Each mission is a building block, contributing to a larger strategic vision. For example, launching more navigation satellites strengthens the indigenous NAVIC system, reducing India's reliance on foreign GPS services. Similarly, deploying advanced Earth observation satellites provides higher quality data for disaster management, urban planning, and climate change monitoring. The upcoming launches before March 2026 are therefore not isolated events, but are interconnected parts of a well-thought-out plan to enhance India's technological self-reliance and its capacity to serve its citizens. This aggressive launch tempo is a clear signal to the world. It shows that India is a serious and reliable player in the global space industry. By consistently launching its own satellites and offering launch services to other countries, ISRO is strengthening its position in the competitive commercial launch market. The coming months will be a period of intense activity at the launch pads of Sriharikota. The roar of rockets will become a familiar sound, each one marking another step forward in India's incredible space odyssey. The countdown has already begun for a series of missions that will shape the future of Indian space exploration and deliver immense value back to the nation. The Gaganyaan program is perhaps the most exciting and ambitious project ISRO has ever undertaken. Its ultimate goal is to send Indian astronauts, called Vyomanauts, into space using an Indian rocket from Indian soil. This is a monumental undertaking that represents a giant leap for the nation's scientific and technological capabilities. The first crewed mission is targeted for 2027. It will carry a crew of 3 astronauts into a low Earth orbit, about 400 kilometers above the planet. They will spend about 3 days orbiting the Earth before returning safely, splashing down in the Indian Ocean. Achieving this would make India only the 4th country in the world to have an independent human spaceflight capability. Before any astronaut can board the Gaganyaan spacecraft, ISRO must ensure that every single system is perfectly safe and reliable. The safety of the crew is the absolute highest priority. To achieve this, a series of rigorous uncrewed test flights are planned. The first of these major test missions, known as G1, is scheduled to take place before March of 2026. This uncrewed flight will be an end-to-end test of the entire system. The LVM-3 rocket will launch the Gaganyaan orbital module into its intended orbit. The module will then perform a series of maneuvers before firing its engines to begin its journey back to Earth, culminating in a controlled splashdown. This G1 mission is a crucial dress rehearsal. It will validate the performance of the powerful LVM-3 rocket, the orbital module's life support systems, its propulsion systems, and its navigation and guidance controls. Every piece of data from this flight will be carefully analyzed to identify any potential issues and make necessary improvements. Following the G1 mission, other test flights are also in the pipeline. These include tests of the crew escape system, which is designed to safely pull the crew module away from the rocket in case of an emergency during launch. Each successful test brings India one step closer to the historic day when it will send its own citizens into the cosmos. The Gaganyaan program is more than just a technological milestone. It is a source of immense national pride and inspiration. It has the power to ignite the imagination of a generation and encourage more young people to dream of careers in science and exploration. The 4 astronaut designates, all distinguished pilots from the Indian Air Force, have already undergone extensive training in Russia and are continuing their preparations in India. Their journey represents the culmination of decades of hard work by thousands of dedicated scientists and engineers at ISRO. The path to sending humans to space is long and challenging, but with each test and every small success, India moves steadily towards its own giant leap. Even for a space agency with a long history of success, the journey to the stars is never without its challenges. Space exploration is an incredibly difficult and unforgiving business, where the smallest error can lead to failure. ISRO faced one such difficult moment recently, on January 12, 2026. On that day, the nation watched as the Polar Satellite Launch Vehicle, on its mission designated PSLV-C62, lifted off from the launch pad. The rocket was carrying a very important payload, the EOS-N1 Earth observation satellite, along with 15 smaller satellites for various Indian and international customers. Hopes were high for another successful launch by India's trusted rocket. Unfortunately, the mission did not go as planned. During the flight, an anomaly occurred near the end of the burn of the rocket's 3rd stage. This caused the vehicle to deviate from its intended flight path, and contact was lost. The rocket and all 16 satellites on board were lost, falling into the sea. This was a deeply disappointing setback, not just for ISRO, but for the entire nation. It was especially concerning because it was the 2nd consecutive failure for the PSLV, following a similar incident with the PSLV-C61 mission in May of 2025. The PSLV has been ISRO's workhorse for decades, with an outstanding track record of reliability, so these back-to-back failures raise serious questions. In the world of rocketry, failure is a harsh but powerful teacher. Immediately following the PSLV-C62 incident, ISRO convened a high-level committee to conduct a thorough investigation. The top priority is to find the exact root cause of the anomaly in the third stage. Engineers and scientists are meticulously poring over every piece of telemetry data sent back from the rocket before contact was lost. They are examining every component, every process, and every quality check involved in the manufacturing and assembly of the third stage. Nothing will be left to chance. The goal is not to place blame, but to understand what went wrong and to implement corrective measures to ensure it never happens again. This period of investigation represents a moment of reckoning for ISRO. It is a test of the organization's resilience and its commitment to excellence. While the failure of PSLV-C62 has caused a temporary pause in the launch schedule and a delay for the customers whose satellites were lost, it will not derail India's space ambitions. ISRO has faced challenges in the past and has always emerged stronger. The lessons learned from this failure will be invaluable. They will be applied to make the PSLV an even more robust and reliable vehicle for the future, ready to once again carry India's dreams and its vital satellites safely into orbit. While human spaceflight and lunar missions often capture the public's imagination, the backbone of any space program is its satellite fleet. These robotic sentinels orbiting our planet are the unsung heroes of the space age, working silently to improve our daily lives in countless ways. Launching satellites is a fundamental and vital activity for ISRO. These satellites serve as India's eyes and ears in the sky, providing critical services that are essential for the nation's economic development, environmental management, and security. From forecasting cyclones to enabling digital banking in remote areas, the impact of these orbiting machines is felt by everyone, every single day. One of the most important roles of satellites is Earth observation. Satellites like those in the EOS-C series, which the failed PSLV-C62 was meant to deploy, are equipped with powerful cameras and sensors. They constantly monitor India's land, oceans, and atmosphere. The images and data they collect are used for a wide range of applications. They help city planners manage urban growth, assist farmers in monitoring crop health and water usage, and enable authorities to track deforestation and pollution. During natural disasters like floods or forest fires, these satellites provide invaluable, real-time information that helps rescue teams save lives and deliver aid to those who need it most. Another crucial function is communication. A large constellation of Indian communication satellites provides the connectivity that powers our modern world. They relay television signals to millions of homes, provide the backbone for mobile phone networks, and enable ATM services across the country. They are especially important for connecting remote and rural areas, bringing services like teleeducation and telemedicine to communities that were previously isolated. By offering satellite bandwidth and launch services, ISRO also helps other countries and international companies place their own communication satellites into orbit, generating revenue and fostering global partnerships. This makes India a key player in the connected world. Beyond observation and communication, satellites are also essential for navigation. ISRO is continuously working to expand and upgrade its own regional navigation system, known as NAVIC, Navigation with Indian Constellation. Just like the American GPS system, NAVIC provides accurate position, navigation, and timing information. This is vital for transportation on land, at sea, and in the air. It is also used for a variety of other applications, from tracking commercial vehicles to synchronizing power grids. By building and maintaining its own satellite systems, India ensures its self-reliance in these critical areas, making the nation more secure and prosperous. To stay at the forefront of space exploration, a country cannot just rely on the technologies of today. It must actively invent the technologies of tomorrow. ISRO understands this perfectly. A significant part of its upcoming mission plan is dedicated to technology demonstration missions. These special flights act as flying laboratories in space. Their primary purpose is not to deploy a commercial satellite, but to test and validate new, cutting-edge systems in the harsh environment of space. These experiments are the building blocks for future, more complex missions, including long-duration human spaceflight and robotic exploration of other planets. They are investments that will pay huge dividends in the decades to come. One of the most promising technologies being tested is electric propulsion. Traditionally, satellites use chemical propellants to adjust their orbits and maintain their position. This propellant is heavy and finite, which limits the operational lifespan of a satellite. Electric propulsion systems, on the other hand, are far more efficient. They use solar energy to generate an electric field that accelerates ions, creating a gentle but constant thrust. This requires significantly less fuel, allowing satellites to be lighter or to carry more scientific instruments. It also means they can operate for much longer. Mastering this technology will be a game changer for future Indian satellites and interplanetary missions. Another futuristic technology on ISRO's test list is quantum communication. In our increasingly digital world, the security of information is paramount. Current encryption methods can, in theory, be broken by powerful computers. Quantum communication, however, offers a new level of security that is considered unbreakable by the laws of physics. ISRO is planning to test a system called quantum key distribution, or QKD, which uses the principles of quantum mechanics to create a secure communication channel between a satellite and a ground station. Developing this capability would be a massive leap forward for securing India's strategic communications for military, government, and financial sectors. These technology demonstration missions are essential for reducing the risk of future projects. By testing these advanced systems on smaller, dedicated flights, ISRO can iron out any problems before incorporating them into big-budget missions like Gaganyaan or future planetary probes. Other technologies being explored include advanced communication systems that can transmit more data faster and new materials that are lighter and more resistant to the extreme temperatures of space. Each successful test builds ISRO's confidence and expands its toolkit, paving the way for more ambitious and capable missions that will keep India at the cutting edge of space science and technology. India's love affair with the moon is set to continue with an even more ambitious and challenging mission. Following the historic success of Chandrayaan-3, which made India the first nation to soft land a spacecraft near the lunar South Pole, ISRO is now setting its sights on the next logical step. The government has given its approval for the Chandrayaan-4 mission, a project that represents a significant leap in complexity. The goal of this mission is not just to land on the moon, but to collect samples of lunar soil and rocks and bring them back to Earth for detailed scientific analysis in labs here in India. This is a feat that only a handful of nations have ever accomplished. A lunar sample return mission is an incredibly complex undertaking. It is like conducting multiple missions in one. First, a lander module must make a precise and gentle landing on the lunar surface, just as Chandrayaan-3 did. But this time, the lander will be equipped with a robotic arm and a drill to collect the lunar regolith. Once the samples are collected, they must be securely stored in a special container. Then comes the most difficult part. A small rocket, called an ascent module, must launch from the moon's surface, carrying the precious sample container back into lunar orbit. This will be the first time India has ever attempted to launch a rocket from another celestial body. Once in lunar orbit, the ascent module must perform a delicate and completely autonomous rendezvous and docking maneuver. It will have to meet up with an orbiter module that has been waiting patiently, circling the moon. The sample container will be transferred to the orbiter for the long journey home. Finally, the orbiter will travel back towards Earth and release a re-entry capsule containing the samples. This capsule will have to withstand the intense heat of re-entry through Earth's atmosphere before deploying parachutes for a safe landing on Indian soil. The entire mission, slated for around 2028, will require flawless execution at every single stage. Bringing a piece of the moon back to India will be a moment of immense scientific importance and national pride. Studying these pristine samples in our own advanced laboratories will provide scientists with invaluable insights into the moon's origin, its evolution, and the history of our solar system. It could help us understand the distribution of water ice and other resources at the lunar poles, which could be vital for future human settlements. The Chandrayaan-4 mission is a bold statement of India's growing confidence and capability in space exploration. It is a challenging journey, but one that promises to unlock new scientific treasures and solidify India's status as a major lunar power. In the grand theater of space exploration, collaboration is becoming increasingly important. The challenges are too great and the costs too high for any single nation to go it alone on every front. India, through ISRO, has always been a strong advocate for international cooperation in the peaceful use of outer space. As its capabilities grow, so do the opportunities for forming powerful partnerships with other space agencies around the world. These cosmic handshakes allow for the sharing of knowledge, technology, and resources. They enable more ambitious missions than would otherwise be possible and help build bridges between nations, fostering a spirit of global scientific endeavor. One of the most exciting upcoming collaborations is a joint lunar exploration mission with the Japan Aerospace Exploration Agency, or JAXA. This mission, known as the Lunar Polar Exploration Mission, or LUPEX, is planned for a time frame after 2028. Its primary objective will be to explore the permanently shadowed regions near the Moon's south pole. These are areas that never see sunlight and are believed to hold vast quantities of water ice. For this mission, India is expected to contribute the lander system, while Japan will provide the H-3 rocket for the launch and a sophisticated rover. Working together, the two nations aim to investigate the quantity and quality of this water ice, a resource that could be critical for future human activities on the Moon. India's partnerships extend far beyond Japan. ISRO has a long and fruitful history of collaboration with NASA, the American Space Agency. This partnership recently produced the NISR, or NASA-ISRO Synthetic Aperture Radar Satellite, a joint Earth observation mission that will map our planet in unprecedented detail. Future collaborations are also being discussed, potentially involving India's Gaganyaan program and NASA's Artemis Accords, which aim to return humans to the Moon. Similarly, India continues to work closely with the European Space Agency and France's CNEs on various scientific missions and for ground station support, which is vital for tracking rockets and communicating with distant spacecraft. These international partnerships are mutually beneficial. They provide ISRO with access to advanced technologies and scientific expertise, while also offering India's own proven capabilities, like cost-effective launch services, to its partners. For example, ISRO's PSLV rocket has become a preferred vehicle for launching small satellites for many countries and universities around the world. This not only generates commercial revenue, but also builds goodwill and strengthens diplomatic ties. As India looks towards more complex missions to Mars, Venus and beyond, these global partnerships will become even more crucial, allowing us to share the risks, the costs, and ultimately, the incredible rewards of cosmic discovery. While the immediate future is packed with launches, lunar missions, and human spaceflight, ISRO is also dreaming much bigger. The long-term vision for India's space program extends far beyond low Earth orbit. The ultimate goals are to establish a continuous human presence in space, send astronauts to the Moon, and eventually embark on robotic and human missions to other planets. These are the grand challenges that will define the next era of space exploration. And India is steadily laying the groundwork to be a major participant in this journey to the ultimate frontier. It is a vision that aims to transform India from a spacefaring nation into a space-pioneering one. A cornerstone of this long-term vision is the plan to build an indigenous Indian space station, which will be known as the Bharatiya Antariksha Station. The initial work on this ambitious project is expected to begin around 2028, with a target of having the first modules operational by 2035. Unlike the massive International Space Station, India's station will be a more compact modular design, weighing around 20 tons. It will serve as a microgravity laboratory where astronauts can conduct long-duration experiments in biology, materials science, and medicine. This station will be a crucial stepping stone, allowing India to master the technologies needed for long-term human survival in space before venturing further out. To build a space station and launch heavier interplanetary probes, India will need more powerful rockets. To meet this need, ISRO is actively developing a next-generation launch vehicle, or NGLV. This new rocket will be a game-changer. It is being designed to be partially reusable, similar to the rockets being developed by private companies in the West. Reusability is the key to dramatically reducing the cost of launching payloads into space. The NGLV will have a much higher payload capacity than the current LVM-3, making it capable of lifting the heavy modules for the space station and launching large robotic missions to Mars and Venus in a single flight. This rocket is expected to be operational in the early 2030s. The final, most audacious dream is to see an Indian astronaut walk on the surface of the moon by 2040, and to send robotic probes to explore planets like Venus and Mars. These missions represent the pinnacle of human and robotic exploration. They are incredibly challenging and will require decades of dedicated work, technological innovation, and sustained investment. Yet, they are the goals that inspire us the most. They push the boundaries of human knowledge and our capabilities. From the initial test flights of Gaganyaan to the development of the NGLV and the Bharatiya Antariksha Station, every mission is a deliberate step on the path toward these incredible, long-term dreams, securing India's place among the leading explorers of the cosmos.